Good morning. Myself, Professor Rajendra G, Department of Electrical and Electronics Engineering. Last class we had seen problems on AC parallel circuit, and the method to solve AC parallel circuit is J method. In J method we had seen what is rectangular form and polar form. Let's take an example. Two impedance 150 minus J157 ohm and 100 plus J110 ohm are connected in parallel across 250 Hz supply. Find the branch current, the total current and the total power in the circuit. Also draw the phasor diagram. Here you can see there are two parallel branches. The first branch is of 150 minus J157 ohm. This is one total impedance. Now why it is 150 minus J157? Because the value of R is 150 ohm and the value of this symbol is nothing but your capacitor, but its value is 157 ohm, which is nothing but R minus JXC. Next, the second branch is Z2 is equal to 100 plus J110. So the value of R is 100 over here and the value of XL is 110 ohm. So always remember that whenever you find a combination of resistance and reluctance, you take R plus JXL. Whenever you find a combination of R, resistance and capacitance, take a equation of R minus JXC. Now Z1 is 150 minus J157, 150 minus J of 157 ohm, which is in rectangular form now. Now we need to convert this back to polar. Let's see how we can convert this. So shift pole, write down the real component and the imaginary component. 150 comma minus 157 say equal to. So you're going to get 217.14. So here it is 217.13. So which is made as 14. Now in order to get the angle, shift F. Then it is alpha F then equal to. So you're going to get minus 46.31 degree. So again, if you want to convert this back polar to rectangular, I'll take rectangular. I'm going to give the values of 217.14 comma minus 46.31. So I've got 149.9, which is nothing but my answer as 150 for Z1. Now I need to find the imaginary component. Again, alpha F equal to, which is minus 157.0, which is the right answer, right? So in the you got to know how we can convert that rectangle to polar and back again to polar to rectangular by using a calculator. Similarly, the Z2 value, which is in rectangular form, is converted back to polar. Now I need to find the total current. So IT is nothing but the total current, which is divided into two parts, I1 and I2. I1 is written as E by Z1. The value of E is 200. The value of Z1. Here you need to take the value of polar only. You cannot take rectangular because we have division. So division operation comes under polar form. So we have to take polar form equation. So 200 by 217.14. Now whenever there is a division operation in polar, the angles are going to get subtracted. So this answer is going to give me 0.921. Here the angles are going to get added, so this becomes plus. Now again you are converting this polar to rectangular form now. Now we have to calculate I2. So the current for I1 is this. I2 is E by Z2. Again E is 200. Now for Z2 you are going to take polar. Why? It's a division form. So division forms comes in polar as we have discussed. So again same thing, 200 by divided by 148.66, and the angles are going to get subtracted, 0 minus 47.73, and you're going to get the answer as 1.745 at an angle of minus 47.73. Again you're going to convert this polar back to rectangular, which is 0.905 minus G 0.995 ampere. Therefore total current IT is equal to I1 plus I2. Now write the value of I1. Why? There is a plus symbol, so we have to use a rectangular form expression only. We cannot take polar and get polar forms and get add. As there is a plus sign, it indicates you have to use rectangular form. So 0.636066, which is of I1, and I2, which is 0.905 minus 0.995. Together, adding the real terms, you're going to get 1.541, and subtracting the imaginary, you're going to get minus 0.329. Again, you're converting this rectangular back form to polar, which is 1.576 at an angle of minus 12.05 ampere. Now, the total answer for current is I is equal to 1.576 ampere, and the angle phi is minus 12.05. So, power factor can be calculated by cos phi. The value of phi is cos of minus 12.05, which is nothing but, again, let's check, cos of minus 12.05, which is 0.98. So here you can directly write this expression over here, or you can simply write 0.98. It's the same. E is 200, I is 1.576. Cos of this, you're going to get 308.26 watt. How do you draw the phasor diagram? Draw a line. Now, so the value of I1 is 0.921 and its angle is 46.31. So draw an angle of 46.31, naming that as I1 is equal to 0.921. I2 is 1.345 and its angle is negative. So draw a negative of minus 47.73, giving I2 as 1.345. Next, total I is 1.576. Again, its angle is 0, a negative. So take an angle of 12.05 and its length is 1.576. Thank you.